Hi class, Miss Larbeck's going to be gone. So your substitute is going to actually say what you're going to do on this paper. This is day 1 and day 2. You're going to finish these papers.
Okay.
So Miss Larbeck's going to show you and her daughter's help.
All right. Thank you, Diana. All right. So the day 1 paper was the introduction to the lab. We use this to also help guide us in our formal lab report on Canvas. Okay. We will come back to kind of the burning of paper here in a bit. And then we practice how to balance an equation and then the procedure. Then yesterday we collected data. Here's all the class data that we collected and the mean, median, and mode. We need to make sure that these are filled out on our line lab report. All right. So you want to highlight that, Diana? Filled out online lab report. So you need to go to Canvas and you need to make sure that in Canvas we have our lab tables filled out with all of the trials and the mean, median, and mode. All right, that needs to be online. You should also have your hypothesis, the procedure, the lab materials, and everything else. All right, so that is important. Okay, now I had a lot of kids struggling with the last question. How does the percent change compared to the class average? Basically, this box here was your percent change, and the mean is another word for average. So I kind of did a sentence starter to help you out. All right. So my percent change was ... You can choose less than, more than, greater than, the same compared to the class average. It really depends. Each class had a different average and each partner had a different percentage. So it's going to vary dramatically. Okay. But this is going to help us with our results. All right. Now on the back side, I'm going to help you with some of those conclusion questions. All right. So the first one was, what kind of change took place when burning steel wool? Was there evidence that there was evident? What evidence was there of this type of reaction? So it was a chemical change. All right, because we saw, and what did you see? It could be a color change. It could be the mass increased. It could be the smoke coming out or the smelling of burning from the steel wool. Okay. What was the product of this reaction? Okay. You made iron oxide, Fe2O3, which is another word for rust. Okay. What were the reactants? It was Fe, which is iron, and we combined it with O2, which was oxygen. All right. Now, why did the mass of the steel wool change as a result of heating? Where did the extra mass come from? Think about the products of the reaction and to the mass. All right. So we need to go back to this equation here. Remember, we have iron, that was the steel wool, and we have oxygen. All right, they're going to combine to create the iron oxide rust. This is a synthesis reaction. So the extra mass came from the oxygen in the air. All right, so when I'm talking about where did the extra mass come from, all right, the extra mass came from the oxygen in the air when burned. This is actually what's known as an accelerated rusting, a fast oxidation. So when we burn the steel wool, it caused a dramatic increase in the mass because that oxygen was being burned quickly with the iron. Now you're going to look up the law of conservation and you're going to write it down. All right. You should be able to do that using either your article or the lab itself from day 1. All right. And then what do you think would happen to the mass of magnesium when burned? We actually did this lab a while ago. We took strips of magnesium and we burned it. But I'll write the equation and you might see something a little bit similar to this. Oops. All right. Gotta balance it out. Okay. So I have magnesium plus oxygen equals magnesium oxide. So what do you think would happen if you had magnesium and you burned it in the presence of oxygen and it created magnesium oxide? All right. Last thing. What else is going on? Okay. So when iron becomes iron oxide, it usually forms the compound iron oxide. Diana, would you highlight this for me, please? Fe2O3, this little thing right here.
Oh,
All right. If you were
right-
able to do
right
this,
here.
yes, that's it. If you were able to do this under perfect conditions, then your compost steel wool would also increase by 30%. All right. Can you highlight the mass 30% more, please?
Where's the mass?
It's right here. Mass 30%. Okay, so how can I explain that? Well, with a periodic table, of course, iron has a mass unit of 56 and oxygen has a mass of 16. I can use simple math and the atomic mass to calculate what the percent change would be. So if you remember, I said we were trying to get to an ideal number yesterday, and some of us got close to that. 30% was that ideal number. So if I know I have 4 atoms of iron, and I multiply that by the mass of 56, that comes out to 224 AMU, atomic mass units. If I know that oxygen has a mass of 16, and I multiply it by 3 because I have 3 atoms of oxygen, that comes out to 96 atomic mass units. Now, according to the law of conservation, matter is not created or destroyed, it's rearranged, all right? And it stays the same. The mass I have on the reactants must equal the mass on the products. Well, 224 plus 96 also equals 320. They are balanced, okay? And so that 96 oxygen is that 30% added in. So if I were to take a calculator, all right, and I were to take, and you want to do it, push 9, 6 divided by, this is that one. You haven't learned that yet. All right, 320. 3,
Right.
3, 2, 0, and then click equals.
Equals.
All right, thank you. Step back. All right, so that's 0.3. So now we're going to multiply that by 100. So type in 100.
1, 0, 1
All right, now click enter or equals.
equals.
All right, and that comes out to 30%. So that ideal number, all right, where did that mass come from? It came from the oxygen. All right. Combined to the rest when burned, or rather combined to the iron when burned. All right. So why didn't the class experience that much data? Why did some of us only cap out at 22%? Well, you got to realize you're middle school kids, okay? So these answers may vary. It could be maybe you didn't burn all your steel wool. Maybe you struggled with the math. Maybe you took out the steel wool and you fluffed it out outside the pan and you lost mass on the table. It could be that maybe you just didn't do all the correct steps in order. There's a variety of different things, okay? So at this point, I'm going to stop the video and I'm going to talk to you about how to write down your lab report. All right, you want to say goodbye, Diana?
Goodbye. We will talk to you in next video.